So we're doing this in MS Paint. We have three main files as of right now in this, display.c, we have input.c, and then main.c. In display.c, we have a couple methods. Initialize display, it kind of just initializes all the parallel communication and such. Clear display, it clears out the display buffer that we have, that I'll get into in a second. Draw text, it pretty much updates the display buffer to have some text that we want to show. Display pixel, draw pixel, I don't have that implemented yet, but it kind of just, it's kind of self-explanatory. You can just draw a pixel on the screen, such as that. Update display, what that does is it pushes out changes from the display buffer onto the actual screen using the library, which we're using U8G. Then the display buffer itself, it is 6 lines, so 1, 2, 3, 4, 5, 6, with 23 characters in each line. I found that worked the best using the font that we have, which I believe that's 5x7. So yeah, that's how that's working. Display buffer is a global variable, and yeah. In input.c, this is where we have all the PS2 keyboard magic happening. Basically, in the PS2 interface, I'm not going to get much into it, but we have two main lines, data and clock. Now, data is the scan code that'll be outputted by the keyboard, which should be read on the falling edge of each clock bit. Clock, it just kind of pulses up and down every time we press a key, and it's sending data. VCC and VSS, that's just for power. This is kind of what a communication looks like. This is for the character A, the scan code for which is 1C, which has been just seen here in data. It's 1C. Start bit, that's always going to be 0. Then stop bit, that's always going to be 1. And we also have a parity check, which this one has an odd parity. So I'm also checking for that in my code. Basically what that is if, okay, so the number of ones in communication, those always have to be an odd number. So let's say if we had 1 here, then the parity bit would turn into 1 to make sure that we have an odd number. In the case of 1C, we have 3 ones here, so that it stays 0 because it's already odd. 3 is odd. The stop bit doesn't count for that. So every time the clock pulses, we go into the interrupt service queue routine. So basically, every time the clock would pulse, I have an interrupt that would trigger, which just reads the data line and stores it into a byte for all the data lines. And then every time we have a fully successful communication, we just store it onto a circular buffer. Here's how kind of that works. We have a read pointer and we have a write pointer. Whenever we write something, the write pointer moves up. Whenever we write something again, the write pointer moves up again. And whenever we read something, the read pointer moves up. For my case, what I'm doing is whenever we get here and then we wrap around, I'm just kind of overwriting all the data that we have in those, which should totally be fine. Our size for this one is 32, so you can have up to 32 scan codes queued up, but this is kind of what I did with 4. In main.c, pretty much we're just initializing everything, and we're drawing some text that is seen here, and then we're just updating the screen in a while true loop, which is basically an indefinite loop. And yeah, that's all.